Hey everyone, welcome to Tea with Taiko. Let's give it a few more minutes for people to join. Hey Daniel, welcome.
Hey Ben, hey Alex.
Yeah, just waiting for Dave because he's going to be presenting an interesting topic today. Okay, just give it a few more minutes. Let's wait for Dave. I've just pinged him.
Hello.
Hey, welcome.
How's it going?
Hey Dave.
Good. Thank you. Yeah, so the whole gang's here now.
Okay, fantastic. Yeah, welcome to Tea with Taiko, everyone. Looks like we have 29 people here, which to me is an awesome size. Some familiar faces. So, today we will be talking about like the Taiko Singularity, which is a topic presented by our CTO Brecht during one of our research days. And to be honest, I don't understand it fully well, but at the least, I hope that I can present some of the ideas that we're thinking about with Taiko and what we kind of imagine Taiko can be. And we can just have some discussions, answer some questions and things like that, and just walk through some of this together. So yeah, with that being said, like maybe I'll share my screen and just share some like notes on some of these topics, and we can just kind of like chill and just talk about some fun stuff. So I'll just share my screen. Okay, can you guys see my screen?
Yep.
Yes, I can.
Okay, cool. So let's just start with painting the picture just a little bit for people who are not super familiar with like L2s, because I think this is even hard for people who work on L2s like us to understand like some of the dynamics of how this will actually look. Okay, so I just want to first go over like why do we even need multiple L2s, and what is this idea of horizontal scaling? So the basic idea is that like well, first of all, like whenever you run a node, like you run it on L1, and this is the same case for L2 as well, there's like a whole history of things that happened that the chain is keeping track of, and a node eventually needs to store all of that data, right? And that data ends up growing a lot over time. And on Ethereum, on like L1, we have a idea of block space, like basically this amount of stuff, these things that you want to do, you have to fit it inside of a block, and it's a scarce resource, right? And in a way, this constrains the amount that the network can grow. It constrains the amount a node can grow, because if the requirements for running a node on Ethereum grow too high, then it's harder for people to run nodes, and the network becomes a little bit more centralized. So the thing is, like, an L2 faces a similar problem to some degree as well, right? Like, we can't just have the state grow like crazy because then the hardware requirements will be too high for like running the network. So we also want to constrain the state growth a little bit too, and like there's some demand for block space. So all of this to say is that the reason why you end up needing multiple L2s is you don't want a single L2 to just monolithically grow a lot of state. And the state of an L2 will end up growing linearly over time with the amount of compute that comes into the network. So like, just like on Ethereum, when you include a lot of transactions, like, you can only fit so many inside of a block. And if the congestion is really high because of like EIP 1559, you end up having to pay more because you don't want the state to grow too high. So anyways, this idea of like multiple L2s is a solution to the problem of the state growing too much. And you can consider this like adding additional L2s in parallel to each other, something which is called like horizontal scaling, right? It's actually something that, it's like a common concept that people use in when designing like any type of system that stores some data. Like even databases usually end up doing this. Okay, and what else did I want to say here is like you basically you don't want to have the blocks be too big either, because of course you want to restrain the state growth. And then the last thing that I want to say here is like, okay, what is a L2 like fundamentally? And like, it's just we're just posting some data on some data availability layer, and then some nodes are just downloading that data and creating the state. And we're just posting like the smallest amount on that data availability layer, and that's why L2s end up being cheaper. So this is what L2s are, and this is why we need like multiple ones. So then now I'll talk a little bit about like what is this Taiko Singularity. So the idea of like the Taiko Singularity is just like a made up word, I guess. This is not like an official name or anything like that. Is like there's like people have been talking about this idea somewhat in the space. Like you may be familiar with like OP stack chains. I recently got shared this tweet where someone is talking about like how for on-chain games you can like let's say you have a game like Sudoku or something like that, right? If you have like so many people playing Sudoku, like they're just going crazy. Like eventually you're going to need multiple chains for your Sudoku app, right? Because the state will be growing too big as well. And in this tweet, the author is kind of saying like, oh, you can just deploy this game on like each rollup and just scale it up. What you call like horizontally as the demand grows, right? So I wish I could visualize this a little bit better, but essentially it's like as the demand grows, you can start adding on more L2s to like deal with the scale. This is kind of the idea of building a this like a Taiko Singularity. So there are a few like elements I'd like to share about this. Like one is there's this let's see here. There's this idea of like the a new precompile on the L2. So this new precompile is this idea of like basically you can call like some L1 contracts like from the L2, and the way that you would end up deploying like a dApp is like, let me see if I can find a good diagram for this. Is so basically within your L2 smart contract, you can call an L1 smart contract. You can just execute the code that exists on the L1. So the way that this ends up looking is like if you want to deploy like some token contract which would work atomically on any layer, and by atomically I mean that like when you do some when you end up transferring a token, there's like two parts that need to occur. You need to do like the mint and then also the burn, but these can't be like out of order. You can only mint it if something has been like burned on the other chain, and usually you have to use like a bridge in order to like demonstrate like that happened. And what you can do here is you can actually just deploy a smart contract on the L1, and you can add this like this bus essentially, or something like this to the token contract, and you can encode like what chain that it came from, right? So like in this case where we have like multiple rollups for like a single type of app, you would kind of like encode in like what chain ID this token came from and which one it's going to, and you keep track of that into this like shared bus which exists on the L1. And then basically what you do is like on the actual L2 or like on multiple L2s, all you end up deploying is a proxy contract. And this proxy contract will just simply call the contract which already exists on the L1, right? So the way you can look at it here is like on this L1, you have like this token contract with the bus, and then on the L2, you have only proxies deployed. And what you can do is like if you need to scale the state of your application, you can just deploy like more instances of the rollup, and just deploy like these proxy contracts, which just call the L1 contract. So it's it's actually quite interesting to like do this approach. I think if I believe like Optimism has also implemented this like static call for like the L1, and it's it's a quite an interesting feature to be able to do this. And yeah, so like one other thing to like mention about this is that's like critical is in order to do this like atomic cross-layer transaction, you need to have some type of shared sequencer. So and a based rollup is considered like one type of like shared sequencer, and the block builder will essentially have to like make sure that you do like inside of the same block you do the burn on like one chain and mint on another. So this is also like a critical feature of it. And yeah, so that's like I think the general overview of what I wanted to present. The main reasons that you kind of want to do something like this is because like eventually like Taiko is with enough transaction volume, the state is going to grow to a size where we're just going to need to start scaling like more chains, and we really want it to no matter what chain you're operating on, it should feel like it's the same chain, like you're just connected to Taiko, even though there's like multiple chains. So I think that like a combination of things like this and then like improvements to like wallets are going to make it feel like you're just like operating on like one chain. So yeah, that's basically what I had. And yeah, we can like just maybe open the floor for some questions. I know that was maybe a little bit hard to visualize, but yeah.
Thank you, Dave. I think I do have maybe one comment. So previously, I think Bragg also called it a cross-chain or multi-chain app. So that
Yes.
into or transact or cross-chain transact or something like that. Is it correct to say, based on your understanding, that if you want to cross multiple layer tools, like I still prefer this like cross layer 2 transaction or cross rollup transaction. So if we cross multiple layer tools, then to make it really feasible, will those sequencers, should they be more centralized to coordinate this cross?
Yeah, right. Exactly. This is probably something that I think we will want, like something like I know Flashbots is working on something like Suave, but something where like if we really want it to be like nicely like cross-chain, like things work very well across like all of these, then it would be nice if there was some type of some type of infrastructure to like build these blocks. Yeah.
So that means that the more centralized the proposers or sequencers are, then the easier these kind of cross-chain application will be, possible. We can always say that if we always shoot for like the max level of decentralization, then we probably need to have like enshrined rules in Ethereum to make this happen, right? So I think that's probably my question. I'm not sure I framed the question the correct way, but yeah.
No, I think I get what you're saying as well, and like it's actually something interesting that I think about a lot with like Taiko, where it's like we being like fully decentralized is not something that makes as much sense when dealing with just like the execution side of things. Like it makes a lot more sense on the consensus and like DA layer on like Ethereum. But for us, like the decentralization is more for like just having a little bit of liveness, but it always comes at a cost of efficiency a little bit, and the slightly more centralized, like the slightly more efficient.
Yeah, agreed. And I want to add to this, like our protocol is designed to be decentralized, but it's so easy to configure it to be your centralized app chain. But if the protocol is designed to be highly efficient and centralized, and you want to make it more decentralized, then it's really hard. So I feel like our chain, our like the Taiko layer 2, our official chain, will stay as decentralized as possible. But I think for app chains who build on top of Taiko, they can choose to be centralized and more like user friendly in providing more better user experience. So I'm not against that at all.
Right.
Saying it's really whether you choose to offer really in-time confirmation for your transactions and better user experience, or you just try to offer decentralization and resistance to like censorship.
Right. And one more thing I'll just share on this because it's on my mind, and I think the community would find it valuable, and maybe we can answer some questions. But on this idea of like configuration, one thing that we've been looking at a lot, and maybe you guys in the community look at this too, is that there's these ideas of like roll-ups as a service where someone can come in and they can just like one click deploy a roll-up, and in a way that product is very enticing to someone who's deploying like a dApp. And I think that like one way you can think of this, if some maybe get this like Web 2 analogy, is like the stack of Taiko is very configurable in the same way that a lot of like platforms, like you may have heard of like Kubernetes or things like that, can be configurable. Like you can configure your backend scaling with this like in any way you kind of like. But I think that there's going to be some default configurations that are like very appealing to most people, and those will just be offered simply in a way that like the analogy I think of is something like Vercel, where you just are like, hey, like this is the thing I want to deploy, and then like this is like the setup that works for me. You just like click some buttons and like and then you're just like good to go. So I think that is like one that's one thing that like we're actively looking at and think in terms of thinking of like, okay, how do we like offer this like block space to developers that like want to use it? And one way I kind of see it emerging. But yeah, so I don't know. Does anyone have any questions or want to hop on and discuss some more?
I'm not seeing any requests to speak at the moment, but it is a big brain topic for a lot of people. So maybe people are still trying to digest everything that's being said. But yeah, if anyone's got any questions or comments or something they'd like to share, please feel free to hop on stage.
Well, I guess I just have a question to clarify. I guess it is a pretty dense topic, and it's basically just so the whole point is that like when you want to scale like Ethereum and you use layer twos, like right now you have the ability to like there's all these other competing projects and different protocols and different L2s, and that's sort of like the plan of Ethereum of how to scale and all that. But what you're saying is you can also like basically like deploy multiple versions, like multiple instances of Taiko to kind of scale Ethereum as well. So you don't really need like all these competing chains. Like it's not just like, how you have like Optimism and then you have like ZK Sync and then you'll have like Taiko, like they'll all be competing, but you don't have one state instance of that on Ethereum. You can deploy multiple instances. Is that kind of the idea?
Yeah, that's definitely in line with it. I guess one way that I would say this, and maybe this alludes to why this topic both sounds a little difficult, but at the same time, maybe shouldn't feel that way. And what I mean by that is that like this idea of like multiple chains is just something we're trying to hide in the background, right? And if you look at the story of Ethereum user experience and kind of the trend of what Ethereum is trying to do, is we're trying to make it look less complicated from the outside, right? Like right now it looks fairly complicated. It's like you go to an app, it's like, okay, you're going to connect to Taiko or Polygon or Scroll or this. And then now we're saying, oh, there's going to be multiple instances of Taiko, thousands of instances of Taiko. And then what? You're just going to switch to like Taiko 1, Taiko 2, like all of this stuff that it's really meant to be more, as you kind of alluded to, like more technical and more in the background. But from the user's perspective, like we want to just abstract that away. So it just looks like a single chain, and maybe like it even looks maybe there's not even an idea of having a chain, right? Like, when you connect to a website, your browser does like a couple of checks to like make sure your connection is secure and make sure there's a valid certificate. Like wallets maybe will do the same thing. It's like, okay, Taiko and Optimism and Scroll, these are cool chains, and like you don't even have a notion of like connecting and making sure this is correct. It's like your wallet or browser is a little smarter and they do all this in the background. So really, I guess the presentation is more about like by doing this L1 call thing and this kind of intelligent way of deploying a proxy and being able to have multiple L2s, we're able to achieve more scale. And this is going to help with our vision of just like making things just look like a single chain, and there's not really, and all of this like scaling is kind of happening in the background, and really the only difference you see is like hopefully just cheap transaction fees. I hope that answers the question to some degree.
Oh no, that really clean explanation. The whole thing that really helped. So that with one delegate call and all that kind of abstracts away from like having to use bridges and stuff like that, and then you can do those like atomic types of having to go through all those steps, and you have like again multiple instances of like background not really paying attention to caring about like which all that it kind of happens in the background with like that abstracted like that and all that.
Sorry, Alex. I honestly couldn't really hear too much. Yeah, apologies for. Maybe you can paste it in the chat too. But the voice is a little choppy. I do see that we got like just in the interest of time as well, that we have some other questions here. Like someone said, hi fam, how modular will Taiko be? Specifically, what layers will be the most modular or configurable if you prefer? And which layers will not be modular at all or much less modular? Yeah, this is a good question. I'm not sure. Maybe I can answer just a tiny bit, and maybe Daniel can maybe expand further on this. But the way that we've constructed our client and our protocol is like to be very modular. So our Taiko client, if you look into that, basically just downloads data from somewhere, and it instructs in the execution engine over this thing, this engine API. And basically, you can swap out that execution engine, and you can also swap out that place where it downloads data from. It's called like a data availability layer. So to modify things like around this Taiko client is not difficult if we wanted to maybe use a different data availability layer where we're publishing these rollup transactions, or if we want to use different execution clients. So those things can change, like the DA layer, the execution client, maybe we'll use like Reth or something else, or multiple clients. But the core protocol, like the logic of how it works, I guess, is the part that doesn't really change. But yeah, that's my response on it. I'm not sure if Daniel has more to say.
That's a pretty good answer, Dave. I think when I think about like moderate-based design, I was like, going forward, if, for example, if ZK Think has a nice module or a component that we can use, and assuming there's no license issue, right? If we have this common principles, adopted, and we can just take their component or module and plug it in to our, a stack, or we pick another one from Stockware, if we can just assemble different modules together to build up a solution, that would be perfect, right? But that's really for the long run. I mean, when things settle down, when we learned enough lessons, but now it's just too early. So our modular design is really just for our own benefit, to make sure, when we upgrade something, the upgradability is going to be easier. So we need to do just as little, as possible to perform the upgrade, right? So that's I think the way we structure our code to achieve this modular design. But it really depends on your definition of like what is a module, right? So I cannot say we are super modular, although some other team claim to be modular design, but at least their module cannot be used by us. So, whether it's modular or not doesn't really make any sense to me. But it's not our near-term goal. But if you look at our code, at least the prover is like a small module. So we have defined our own interface to interact with different proof verifiers. So we can upgrade that easily without modifying the core protocol. You can call it like component-based design or something like that. So it's the code is structured pretty well. But I would not call it a modular-based design. It's kind of like a little bit too early and over stating like our principle a little bit.
So, thank you, Daniel. We have time for one more question, and we've got Andy Bosch, who wants to ask a question. Let me just see if we can bring him on stage. Andy, you're on stage.
Yeah, hello guys. Thank you for introducing this topic to us. It was very interesting and cool speech. I just want to ask one question. Like Dave was talking about contract in L1, and you can reach them from L2, and you can do it from different like proxies to make more scalability. And I just want to know if it is more safe to use one proxy or different proxies, or no? How it affect security? Like if it's better for blockchain to use one proxy or multiple proxies.
Wait, so using one proxy or multiple proxies? I think that like I'm not 100% sure if I understand the question, but there would be like the idea is to have a proxy deployed for like each instance you want the app to be on the L2. In terms of like the security, I believe that the security would still be like trustless because the L2 is just running in its own trusted like L1 node in order to do the to simulate the call to the to the L1 contract. So in this sense that like I think the security is still good. Yeah, and it would be like multiple proxies deployed.
Yeah, thank you. I'm sorry if it was stupid questions. A stupid question. I just I'm not like developer. I don't understand some things, but I just was interested in this question. Thank you.
Oh, thank you for asking.
It's not a stupid question because other terms, are not like we don't really even agree on the same side of terms. So that's why some questions is confusing. Even internally, when we discuss something is about this like a cross-chain rollup, a cross-chain app, or a cross-chain transaction, is also very confusing now.
Right.
Okay, we've come to the end of today's session. I hope everybody found it informative and useful. I certainly did. So thank you very much for attending. So just a reminder, we have these calls once every 2 weeks, and alternating in between these, we also have office hours where people could just come up and ask any questions they like. And the Tea for Taikos are just like these sessions where we give some sort of tech talk or some educational sessions or some sort of demo. And you guys are welcome to join either of those or all of them. And these sessions are also recorded. So if anybody misses them or wants to catch up on previous ones, they can catch up on our YouTube channel. Thank you very much, everybody, for joining and for asking questions. It's what makes these sessions interactive. So thank you very much, and I will close the call. See you next time. Bye, everyone.
Thanks, everyone.